So hello everyone, welcome back to Hasvora Education. Today we'll be solving the Chemistry 9701, Paper 1 Variant 2, and this is the MCQs paper of the recent session of the May-June 2025, and the time allowed for this paper is 1 hour and 15 minutes, and the total marks for this paper are 40 marks. Okay, so before starting the video, I would like if you can just subscribe the channel and just share this video with anyone you think it could benefit. Okay, so let's start. So question number 1 says, consider the following statements. So in this question, what we have to do is that based on the validity of these two statements, we have to give our answer. Okay, we have to state that which of the statements are correct. So statement 1 says that silicon dioxide has a higher melting point than sulfur dioxide. Now remember that silicon dioxide SiO2 has a giant covalent structure. Okay, it has a giant covalent structure. So this is the example that has been included in your syllabus along with the graphite. Okay, it is also a giant covalent structure, and diamond is also a giant covalent structure, while sulfur dioxide, it is a simple covalent structure. So this states that the giant covalent structure actually have strong covalent bonds, and it will have higher melting point than sulfur dioxide. So this statement is actually correct statement. Okay, so statement 1 is correct. Now the second statement is that ammonia has a higher boiling point than the phosphine, which is pH 3. Now this also states that ammonia has stronger bonds than phosphine. Now first of all, what bonds are included in ammonia and the phosphine? Both have intermolecular forces. Okay, both have intermolecular forces of attraction. Now you have to see the degree of the intermolecular forces. Like for example, we have the tempered dipole, we have the permanent dipole, and then we have the hydrogen bonding, which is the strongest. Okay, so the hydrogen bonding occurs whenever a hydrogen is bonded, it is bonded to any of these. Okay, which is fluorine, oxygen, or nitrogen. So whenever the hydrogen is directly bonded to these three atoms, any of these, this is the most electronegative atoms. Okay, so it will actually have a hydrogen bonding. So now you can see in ammonia we have a lone pair, and now it is bonded to three hydrogen atoms, and it has a trigonal pyramidal structure. Okay, with a 107-degree bond angle. So it actually has this hydrogen bonding. Okay, so it has the hydrogen bonding, which is the strongest intermolecular forces. Okay, then for the phosphine, which is pH 3, it also have a lone pair because it also in group 5, and it has 1, 2, and 3H. Now because of the electronegativity difference, the hydrogen atoms will have a partial positive and the phosphine will have partial negative charge. Okay, and because of this, actually permanent dipole only exist. Okay, so the permanent dipole will only exist, and actually the hydrogen bonding is stronger than the permanent dipole. It means ammonia will have a higher boiling point than phosphine. So this statement is also correct. So the answer for this statement will be option A. Okay, this will be the answer. Now let's move on to second question, which says that how many neutrons are contained in an atom of iron with a mass number. Now this is the mass number, or you can say the nucleon number. So what is the nucleon number? It is the, you can say, the sum of the neutrons plus the protons. Okay, now what is iron? Okay, so iron has a mass number, you can say the nucleon number of 60, and it has atomic number, or you can say the number of protons, it has 26. Okay, it has 26 you can say protons. Now how do you obtain the neutrons? So neutrons will be the nucleons, so minus 26. Okay, you will get the neutrons. So let's do this. So 60 minus 26, it will be 34. Okay, so this means that C will be your answer. Now let's move on to question number 3. So question number 3 says the diagram shows a Boltzmann distribution of a molecular energies for a gaseous reaction at two different temperatures and two different activation energies. Okay, so they have given you the graphs for two different activation energy and the two different temperatures. Okay, so which combination of the temperature and activation energy will give the highest rate of the reaction? First of all, to solve this question, you should know that the rate of reaction is directly proportional to the temperature. Okay, so it means that if higher temperature, higher the rate of reaction. Now how do we know that which temperature is higher and which one is lower temperature? Now you can see that on the y-axis we have the proportion of the molecules, and on the x-axis we have the energy of the molecules. This means that the particles that are here will have more energy than which are here. Okay, so you can see this graph. Let me just highlight this one. Okay, so this graph actually has more particles that have more energy. You can see this area is actually the particles with more energy. Okay, and this graph indicates that there are more particles with more energy. So this means that this temperature is actually a higher temperature. Okay, so T2 is your higher temperature. So first of all, what we can do is that we can cross out all of the options that do not involve T2. Okay, then about the activation energy. Now activation energy is a threshold. For example, if I conduct a test, it is of 80 marks and I set the passing marks as 30. So many of the students might fail. But if I lower the threshold, I lower the marks that are required to pass the test, then more of the students will pass the exam. Okay, so it is also like the activation energy. So if I lower this activation energy, or you can say the energy barrier that is required for the reaction to occur, this means more particles, or you can say the molecules, will able to be reacting together. Okay, so this means that the EA1, which is the activation energy 1, it is actually indicating that more molecules have the energy to react together. Okay, so this means that the activation energy 1 has higher rate of reaction, because the rate of reaction is what? It is that how much the reactant is converting to the product. Okay, and it can only convert when it reacts together. So EA1 has higher rate of reaction. So T2 and EA1. Okay, so C will also be cancelled, and hence D will be our answer. Now question number 4 says that the reaction between sulfur dioxide and oxygen has equation shown. Okay, so you can see that 2 moles of SO2 are reacting with oxygen to form sulfur trioxide. Okay, and they have given you the delta H, which is negative. Okay, so this actually means that this is a exothermic reaction. And you should remember that the exothermic reaction always and always favors the yield when there is a lower temperature. And starting with that, we can actually now read the second line, which says that 1 mole of SO2 and 1 mole of oxygen are placed in a closed container and heated to a constant temperature. Okay, so initially the reactants, which are SO2 and O2, their you can say quantity has been given. They are all both 1 mole, and at this temperature, when it actually reaches the equilibrium, there are 0.8 moles. Okay, you have to focus on this. There was 1 mole of each of the reactants, and at the equilibrium there was 0.8 mole of SO3. So now first of all, what we have to do is that we have to write each of them. So this is SO2, this is O2, and this is your SO3. Now what is the initial? Because we use the derivation, which is ice. Okay, so I means the initial, C means the change that is occurring, and E means the equilibrium, you can say quantity. Okay, the quantity that is obtained at the equilibrium. So first of all, we have 1 mole of SO2 in the initial stage, and we also have 1 mole of O2, but we have 0 mole because the reaction is just starting. Okay, and now what is the change? The change is 0.8 because in the equilibrium we have 0.8 mole of SO3. Okay, so if 0.8 mole of SO3 is the change that is occurring, now you can check the you can say the ratio between the SO3 and the O2. So it is 1 to 2. This means if 0.8 is the change that is occurring for 2 moles, it will be 0.4. Okay, it will be 0.4 for O2 and it will be the 0.8 for SO2, because there are 2 to 2 ratio, which means 1 to 1 ratio. Okay, so the change is 0.8 for SO2 and 0.4 for O2, but it will be negative because the reactant is going to be used up. So at equilibrium we will have 0.2 mole of SO2 and 0.6 mole of O2 because we have subtracted it from 1, okay, the initial concentration. Okay, now let's read the statements. Which statement is correct? The equilibrium partial pressure. Okay, now what is partial pressure? The partial pressure is actually the mole fraction, your mole fraction. And what is mole fraction? For example, if I am finding the partial pressure for SO2, it means that the moles of SO2 at the equilibrium divided by the total moles into the pressure. Okay, so mole fraction and into the pressure. Let's move it here a little bit. Okay, so this is actually your formula for the partial pressure. Okay, now the equilibrium partial pressure of the SO2 is greater than the equilibrium partial pressure of O2. Now let's check. Okay, so if I'm just checking for the SO2, so how many moles I have in the equilibrium? It is 0.2. And what is the total number of moles? It is 0.2 plus 0.6 plus 0.8, so it will be 1.6. Okay, now you can just see this by looking at the fraction. Okay, so the more the numerator is, this means the more the partial pressure will be. Now let's check for the O2. Okay, so it will be 0.6 divided by 1.6. Now you can clearly see that the O2 partial pressure will be more, so this means that this statement is actually incorrect. Okay, now B part says that Kp has units of mole dm cube. Okay, now you can just clearly see this, that you can just form this expression. So it is product over reactants. Okay, so it is SO2, let me just, okay, SO2 and sorry SO3, and then the quotient becomes the power, so it will be squared. This means mole square dm minus 6, and we have SO2, the quotient becomes the power, and into O2. Okay, so actually what will be the units in the denominator and the numerator? So it will be mole square dm minus 6 divided by, now we have mole square dm minus 6 in the numerator as in the denominator as well, but it is going to be multiplied with the mole dm cube. Okay, so it is going to become mole cube dm minus 9. This means we are going to be having 1 over mole per dm cube, or you can just say that mole minus 1 dm cube. Okay, so it is actually mole minus 1 because it is going to be shifted to the numerator, and dm cube. So this is also incorrect. So at a lower at a lower temperature, the equilibrium amount of SO3 is lower than 0.8 mole. Now I have told you that exothermic reaction always favors the yield at higher at lower temperature. Okay, so if there is a lower temperature, the equilibrium amount of SO3, which is actually your yield or your product, it actually needs to increase. It will be greater than 0.8 mole, not lower than. So C will also be incorrect. And then the D part, the mole fraction of SO3 is less than 0.8. Let's check the mole fraction. So the mole fraction for the SO3 will be the moles of SO3, which is 0.8 divided by total moles, which is 1.6. So 0.8 over 1.6 will be how much? It will be 1 by 2, or you can just say 0.5. So now it is correct. It is less than 0.8, which is 0.5. So our answer will be part D. Now the fifth says that red lead is a red pigment with the formula of Pb3O4. Every formula unit of red lead is the same. Each formula unit contains 3 lead ions and 4 oxide ions. Lead has 2 different oxidation states in lead. What are the oxidation states of lead in the red lead? Okay, so first of all, To solve this type of question, you should always know that this is actually a neutral compound. So what do I mean by neutral compound? The total charge on this compound is 0. So what this means? This means that the oxidation states are actually balancing each other out. Now we do not know for the Pb, and that is what we are going to be figuring out, but we do know for the oxygen. Okay, so Pb3, let's write it as this, and oxygen has -2, but it is 4 atoms, so it will be into 4 is equals to 0. Okay, so this means Pb3 is equals to it will be -8 first. Let's just go systematically first. Okay, so it will be Pb3. This means 3 atoms of Pb, and -2 into 4 is -8 is equals to 0. Now I need the oxidation states such that it actually balances this -8, so it is going to be +8, and it actually gives us 0. Now you can just try all of them. So if I just pick the first one, okay, if I just pick this one, so it will be Pb3. So let's just pick so it will become 2 plus 2 into 2, and then plus 1, it will become +5. This cannot balance this. Okay, you can clearly see this. Now let's see for the other one. So this will be 3 into 2, which will be +6, and +1, so it will be +7, and this can also not balance this. Okay, so let's see for the C. So it will be, if I just say that 2 atoms of lead have the oxidation state of +2, so 2 into 2, it will be +4, and then we have a +4 also, so it will be +8. Now this one actually is actually verifying or validating the answer. Okay, so this will be your answer, C. Okay, I hope you understand this. Let's move on to question number 6. So question number 6 says that some standard enthalpy of combustion data are given. Using this data, what is the enthalpy change of formation of methanol? Now they have given you the standard enthalpy change of combustion, and they are asking you for the formation of ethanol, the methanol. So what you have to do is that you just have to make a Hess cycle. Okay, so what I'm going to be doing is that, what is the formation standard enthalpy change of formation? It is when 1 mole of compound is made from its constituent elements. Okay, so what are the constituent elements of the methanol? First of all, what are the elements that are being required in the methanol? It is carbon, oxygen, hydrogen. Okay, so carbon plus oxygen plus hydrogen, okay, and it is actually, this is the formation delta HF, okay, and this is forming CH3OH. Now they have given you the combustion of each of them. Okay, and now you should know that every substance, whether it is carbon or hydrogen or the methanol, it is actually made of the carbon compounds. Okay, so actually each of them reacts with oxygen, or they are oxidized, or you can say they are combusted to form CO2 plus water. Okay, so you can just clearly do it like this. Okay, one arrow like this, so it will be CO2 plus H2O. Okay, and this methanol will also combust to give the same. Okay, now but you can just now plug in the values. So for the carbon and the hydrogen, it will be -394 and -286, and for the methanol it will be -726. Now you just have to follow the direction. Okay, so actually we just go like this. Okay, clockwise. So it will be, the delta HF will be equal to, now you can also do it like this. So it should go like this first, and then it should go like this. Now the ones that are with the arrow should be with the same sign, and the other ones that are opposing, or you can say in the opposite direction, you have to reverse its direction. So it will be -394 -286. Okay, and actually then we have to plus the other one, so plus 726. So let's see what is the answer. -394 -286 and plus 726, so it will be plus 46. So delta HF, or the delta H formation of the methanol, is plus 46. Okay, so this is the answer, C part. Okay, let's move on to Question number 7, which says which row is correct. So we have to arrange this in the smallest bond angle to the largest bond angle. Okay, now for each of them you should know what is the bond angle. Okay, so for H2O you should know that we have oxygen that is binded to 2H atoms. Okay, and it actually have two lone pairs. Okay, so if there are two lone pairs, there is a bond angle of 104.5 degrees here. And for the ammonia we have N, a nitrogen, it has a lone pair and it has 3 hydrogen atoms. Okay, and it has a bond angle of 107. And for the BF3, which is you can say the boron, which is just bonded to 3 fluoride atoms, so it is 3 fluoride atoms. Okay, so it has a angle of 120. Now you can just arrange it, so H2O, then NH3, and then BF3. So the first row looks correct, so this will be your answer A. Okay, let's move on. Now question number 8 says, in the Haber process the reaction between the two gaseous reactants require the use of catalyst that contains the transition metal. What is the metal and in the which mole ratio do the gases react? Now you should know what is the Haber process, in which actually the ammonia is being, you can say, synthesized. Okay, and what reacts in that? Nitrogen plus the hydrogen reacts to form ammonia. Okay, it forms NH3. Now let's balance the equation. So if I just try to balance this, I need one atom of nitrogen, it will be 1 by 2, and for the hydrogen I need 3, so it will be 3 by 2. Okay, and if now you have to write it in the whole, you can say the coefficient should be whole number, so let's multiply this whole equation with 2. This will become N2 plus 3H2 and 2NH3. Sorry, just give me a minute so I can just erase this. So 2NH3. So now what is the ratio between the gases? It is 1 to 3. And now what is the catalyst used? You should remember it. It is iron, Fe. Okay, and the vanadium, now this one is given, this is used in the contact process. Okay, not in the Haber process. So iron, and it is the ratio 1:3. So B is looking your correct answer. Okay, now question number 9 says aqueous hydrogen peroxide H2O2 decomposes in water and oxygen in the presence of a suitable catalyst. Okay, so you should know that the suitable catalyst is actually magnesium oxide, and now they have given you that 50 cm cube of 0.5 mole per dm solution of hydrogen peroxide produced 120 cm cube of oxygen in 2 minutes. The volume of gas was measured at room condition. What is the average rate of decomposition of hydrogen peroxide during this 2-minute time period? Okay, so what we have to do is, first of all, you should know that the rate of reaction is always and always measured according to the limiting reactant. Okay, it is also and always measured according to the limiting reactant. So first of all, let's check the moles. So the moles of H2O2, it is 0.5 is the concentration into 50, and now it is in the cm, so let's divide by 1000. So it will be let's check, so 0.5 into 50 divided by 1000, so it will be 0.025. Okay, 0.025 moles. Now let's check the moles for the oxygen. So we have 120 cm cube. Okay, and what is actually the gas, the volume of the gas that is occupied for 1 mole? It is 24,000 cm cube, or you can say 24 dm cube. Okay, so it will give you, let's see, so 120 divided by 24,000, it is 0.005. 0.005. Now you can clearly see that this is the limiting reactant. Okay, the oxygen is your limiting reactant. So this means that I have to perform the calculation according to the oxygen. So now what I have to do is that the hydrogen, let me just give me a second. So hydrogen peroxide is decomposing to H2O plus oxygen, so we have to balance the number of oxygen, so it is 2, so this will be 1 by 2. Okay, so now if the oxygen is the limiting reactant, I have to look for the moles of that. So this is 0.05. So for the hydrogen peroxide it will be into 2 because there is 1 to 2 ratio. So for the hydrogen peroxide it will be 0.01 mole required. Okay, and if there are 0.01 mole that is actually you can say being decomposed in 2 minutes, so you have to look for the rate of decomposition per second. So what is 2 minutes? It is 2 into 60 seconds, so it will give you the answer 0.000 and 0.83 more dm³ per second. Okay, so this means that A is your answer. Now, question number 10 says the average intermolecular forces in water are much stronger than the average intermolecular forces in steam. Okay, so the average intermolecular forces in ice are slightly stronger. Slightly means very minimal. Okay, you can just ignore this fact. So then the average molecular forces in water, enthalpy changes are associated with the equilibrium process. So you can see that the H2 in liquid form is converted to the gas or the steam, and the solid is converted to liquid. So which statements are correct? So first of all, you can just see it that whenever a liquid is just turning into the gas, it means that it has absorbed the energy. Okay, sorry, it is not absorbed the energy. Let me just give me a second. Okay, so now the H2O liquid is being converted to H2O gas. So this means it is actually you can say it is a negative, you can say enthalpy change reaction. Okay, and same for the solid, it will also be converted to the liquid. So how is the solid being converted to a liquid? Okay, so what it will do is that it's going to be releasing the energy. So this means that both of these reactions are actually the exothermic reactions. Okay, so it is a exothermic reaction. Now if this is the exothermic reaction, so now you have to look at whether the HB or the delta HM is, which one is the greater one. Okay, so first of all, now if you are actually turning a liquid into a gas, you have to break more of the intermolecular forces, because you are actually they have more energy when it is converted to a steam or a gas. So this means that the HB will actually be greater. Okay, so this means that both of these statements are correct. Let's check for a third one. The intermolecular forces in ice and the water are of same time. This is also correct, because no matter what, the intermolecular forces remains the same, which is hydrogen bonding. Okay, so the answer for this one is A. Now question number 11 says that an experiment is carried out to determine the value of X in a hydrated lithium. Now X is the number of moles of water in lithium hydroxide. So LiOH dot XH2O. A sample of solid is heated in a crucible over a Bunsen flame. So complete dehydration takes place. Decomposition does not occur. Okay, they have given you the mass of empty crucible, the mass of a crucible with LiOH dot XH2O, which is actually your hydrated. Okay, so it is hydrated. This means it has the water in it. Okay, and the mass of crucible and residue after heating, this means that it is anhydrous. Okay, it does not have the water now. So which equation gives the correct value of X? Now do you remember that what was the procedure for your calculating of X? You need the moles of LiOH, and you also need the moles of your H2O. Now how will you get in case of this one? Okay, so how will I get the LiOH that is anhydrous? First of all, I need the S, because it is the mass of the crucible and the residue after the heating, and I actually need to subtract it from the mass of empty crucible, because it will give me the value of the LiOH only. So it will be S minus Q, and divided by, you can say, the MR of the LiOH, so it will be OH, which will be, let's calculate this. So oxygen is 16, so 16 plus 1 is, let me just calculate this. Okay, so 16 is for oxygen, 1 is for hydrogen, and 6.9 is for your lithium. It will give you 23.9. Okay, so divided by 23.9. And then how are you going to get the water? Okay, so water is actually it is being, you can say, evaporated in the heating. So it is the difference of these two. Okay, so S minus R divided by the mR of water, which is 2 hydrogen, so 2 into 1 plus 16 of the oxygen, so it will become 18. Now the ratio always means that divided. Okay, for example, if I write 1:2, so I can also write this as 1/2. Okay, so now I'm going to be writing this as in the fraction form. So this will be S minus Q divided by 23.9, and this will be divided by S minus R divided by 18. So if I just reciprocate this, this will be S minus Q into, so I'm just going to be writing as 18. So let's just reciprocate this. Let me just move this a little bit down. So it will be S minus Q into 18 and 23.9. I actually reciprocated the first fraction, okay, into S minus R. Okay, so you can just simply write it as 23.9 into S minus R divided by 18 into S minus Q. So what option looks similar? It is your option C. Okay, so option C is your answer. Now question number 12 says a sample of ideal gas occupies 250 cm cube at 37 Celsius and 100 kilopascals. How many moles of gas are present in this sample? Now first of all, you actually have to apply the equation of the ideal gas, which is PV is equals to nRT. Okay, so PV is equals to nRT, where n is the number of moles. Let's rearrange this. This will become PV divided by RT. Now the pressure needs to be in pascals, so it will be 100 into 10 power 3, which is 4 kilo pascals, and then the volume needs to be in dm, so 240. Okay, and it is in the cm cube. This means I have to divide by 1000, so divide by 1000 and then divided by the RT. What is R? It is the molar gas constant, which is 8.31, and into temperature, which is going to be in the Kelvin, so 273 plus 37. So when you obtain the answer, let's see what will be it. Okay, so it will be, let's calculate this. So 100 into 10 power 3 into 0.24 divided by 8.31 into 273 plus 37. So it will give you the answer of 9.32 into 10 power minus 3. Okay, so let me just check one more time. So 100 into 10 power 3 into 0.24 divided by 8.31 into 273 plus 37. Okay, so it will give you 9.316 into 10 power minus 3. Okay, so it will be into 10 power minus 3, so it will be B. So B is your correct option. Now question number 13 says under certain conditions CCl4 and H2O react as shown. The activation energy for the reaction is plus 62 kilojoule per mole. Now they have also given you the reaction, and now you can see that delta H is negative. This means that you can say the products have less energy than the reactants. So actually it will be moving down. For example, if this is your product, so it will be moving down, and this is actually your 61.5 minus 61.5 kilojoule per mole, which is the energy difference. But we also have the activation energy, and for that we actually need to see the hump. Okay, so first of all, what I will do is that I will just cancel out the B and the C because it is for the endothermic reaction, okay, not the exothermic. And for A and D, how will I decide is that you can see the activation energy is 62. It is 62 kilojoule per mole. Okay, it is always positive. And for the delta H, it is minus 61.5. Now you can see that they are actually quite, you can say, close values, so they need to have the same range. For example, if the activation energy is rising this much, so the enthalpy change should also be of the same magnitude or close to that. Okay, so A makes no sense of this, so this means that D will be the answer. Okay, because you can see that the hump, now this hump for the activation energy is the same as this delta H change. Okay, so D will be your answer. Now 14 says a helium ion contains 2 protons, 2 neutrons and 1 electron. The helium ion and proton are passed separately through a uniform electric field. The particles are traveling at the same velocity, which arrow describes the path of each particle. Now both of the helium ion and the proton both are positively charged. This means that both are going to be attracted to negatively charged plate. But how we decided which one is actually your beam for your helium and your proton? Now you can see that both of these, actually the fifth and the fourth, are your you can say the beams that are being attracted to that negative plate, because now we have to actually refer to that the helium is more heavier. Okay, it is more heavier, while the proton, it is a lighter molecule. Okay, so it is a lighter particle, so this means that a lighter particle will deflect more sharply. This will deflect more sharply than the helium one. Okay, so this means that the fifth one is your proton and the fourth one is your helium. So let's see. So now you can see that they have confused you in the C and D with the same logic. Okay, so the fifth one is your your proton and the helium is fourth one. Okay, so this means C is your answer. Let's move on to question number 15, which says the skeletal formula of the arginine and lysine are shown. Which row is correct? So you have to just deduce the empirical formula and the MR. So let's see. Okay, so let's count first of all. So 1 carbon atom, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. Okay, so we have C6 here, C6 here as well. Now let's count the number of nitrogen atoms. Okay, so it is 1, 2, 3, 4. So N4. Now let's check for the hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So H14. And how many oxygen? 1, 2. Okay, so O2. Now let's check for other one. So 1, 2. So 2 nitrogen atoms, and then the hydrogen ones 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. H14, and the oxygen is 1 and 2. So O2. So now you can just see that if I just calculate the empirical formula for this, it will be C3NH7O, and for this one it will be C3N2H7O. Okay, now which one matches? Now you can just see that the arginine matches. Okay, now the arginine does not match here, so we can just cancel B. Now the lysine, it does not match with this one, so D will be also cancelled. And actually the C and the A are matching the empirical formula. Now let's calculate the MR. Okay, so if you just calculate the MR, it will be 12 into 3 for the lysine, 12 into 3 for the carbon, and plus the nitrogen 14, and 1 into 7, which is 7 plus 16. Let's calculate this. Okay, let's be quick. So 36 plus 14 plus 7 plus 16. it is let's just say 73. Sorry, I've calculated the mass for your empirical formula, so sorry for that. It will be 12 into 6 plus 14 into 2, it will be 28 plus 14 hydrogen, and 16 into 2 is 32. So 12 into 6 plus 28 plus 14 plus 32, it will be 146. Okay, 146, and this is actually matching, so it means that this was also cancelled. Okay, so now they have given you the mass correct only in the D1, so this means that the C can also be cancelled, so A will automatically be your answer. Okay, but we can just still calculate it. Okay, so it was actually 12 into 6 as well, plus 14 into 4, so 14 into 4 plus 14 hydrogen atoms, 14 plus 2 oxygen, so it will be 32. So 12 into 6 plus 14 into 4 plus 14 plus 32, it is 174. Okay, so it is 174, so this means A is correct answer. Let's move on to question number 6. Sorry, question number 16. So question number 16 says the oxide and the chloride of an element X are separately mixed with water. The two resulting solutions have the same effect on litmus. Now let's see that which oxide and chloride of which element actually has the same result. Okay, so if you see for the aluminium chloride, and for the aluminium oxide, which is Al2O3. Now aluminium oxide actually does not react with the water, and if it reacts, it is actually a basic oxide. Okay, it is a basic oxide, and the chloride actually produces the chloride ions, which actually reacts with the hydrogen ions to produce HCl. So this will actually have a you can say it will give the result red with the litmus, and this will give you a basic nature, so it will be blue. So it does not have a same result. Now let's see for the calcium. Okay, so let's see for the calcium. So calcium oxide, okay, it is a basic oxide, it is sparingly soluble, it gives you a pH of 12 to 13. Okay, and if you see for the calcium chloride, okay, it is actually you can say a salt. Okay, and is also you can say close to the neutral solution. Okay, so it is also more than 7, so it does not give you the same result. Okay, it will give you, one will give you a basic nature for the calcium, and one will give you a neutral solution, so it is also not your answer. Let's see for the NaCl and Na2O, which is a sodium oxide. So sodium oxide is actually basic in nature, and it is actually basic, and it will give you more than pH 7, while sodium chloride is a basic salt and it gives you pH of 7. So they also does not have the same effect on litmus. Let's see for phosphorus. So if you look for the phosphorus, so phosphorus oxide, which is phosphorus pentoxide, P2O5, if it reacts with the water, it will give you H3PO4, which is an acid, okay, with a pH of 3, and for the PCl5, it will give you HCl, okay, which is also close to you can say pH of 2. So both actually have the same effect, both will give you red color with the litmus. Okay, so this means that phosphorus will be your answer, D will be answer. Okay, question number 17 says, why do the halogens become less volatile as group 17 is descended? So actually what happens is that we move from fluorine to chlorine, then bromine, then your iodine, and then your astatine. Okay, so what actually happens is that the you can say the state is also changing. Okay, it is changes from the gas to liquid and then the solid. Okay, and what actually happens is that the number of the number of electrons are increasing down the group. Okay, it increases down the group. So what is increasing? The temporary dipole forces, or you can say the van der Waals forces, or the intermolecular forces between the molecule, actually you can say it becomes more. Okay, so the number of electrons are increasing. So you can see the statement for C, the number of electrons in each molecule increases. So C will be your answer, because it increases your intermolecular forces attraction, your temporary dipole forces. Okay, because they're homonuclear um, molecule, so it will not have permanent dipole. So it actually increases the temporary dipole forces. Now let's see for 18. Compound M is a white solid. It is chloride of period 3 element. Okay, it is chloride of period 3 element. So information about some reactions starting with compound M is given in the table. Okay, so now you can see that all of them are the period 3 elements, and they are giving you the chlorides. Let's first read the question. Okay, so compound M is first of all added to the non-polar solvent. It gives you a colorless solution, and then the compound M added a little at a time to water, so steamy fumes Q are seen, and the colorless solution becomes the R. So fumes Q tested with the moist blue litmus paper, and it turns red. Now this is an important point. Okay, this is an important point because it tells you that the fumes Q are acidic. Then the solution R plus few drops of NaOH and excess NaOH. So it is a white precipitate which dissolves to give a colorless solution. Now the last one, this last statement, which is about the test for NaOH. So it is enough to deduce one conclusion, that it can't be your magnesium, because magnesium does not give you a colorless solution, and it does not dissolve with NaOH. Okay. Now what we else can we see is that the phosphorus pentachloride. Okay, phosphorus pentachloride, for example, if in the case if the compound M is phosphorus pentachloride, this will react with a non-polar solvent. For example, if I say it reacts with anything, and actually I just add it to H2O. Okay, I just add it to H2O because they have said that compound M is added a little at a time to water, so it actually produces HCl plus it also produces H3PO4. So actually it produces two solutions. Okay, it produces two colorless solutions. It does not produce your steamy fumes. So C can also not be an answer. Then let's see for the D, which is the sodium chloride. So sodium chloride can actually it actually reacts with your water and actually dissociate into ions. So it will be Na plus plus Cl minus. Okay, and it does not actually form any steamy fumes. Rather, it actually forms sodium hydroxide. Okay, which is a basic oxide and is dissolved. Okay, so this will also be not your answer because it does not produce any fumes. So your only answer will be aluminium chloride. Okay, because AlCl3, the aluminium chloride reacts with the water to produce your aluminium hydroxide, and also it produces the chloride ions which reacts with the hydrogen in the water to produce HCl, which are steamy fumes, and also the aluminium is dissolved to give a colorless solution with excess of NaOH. So A will be your answer. Now question number 19 says which statement about strontium and its compound is correct. Okay, so let's see. So you should know that the thermal stability, because this is from the group 2, so the thermal stability increases down the group. Okay, about the solubility also increases down the group, and this is the solubility of actually your hydroxides. Okay, and for the solubility of your sulfates, it decreases. Okay, the solubility of your sulfates. So the sulfate solubility decreases. So now let's read the statement. So sodium hydroxide is more soluble than barium hydroxide. So now this is not correct because the barium is actually lower than strontium. Okay, so barium is lower than your strontium. This means it is more soluble. So barium is more soluble. Strontium is less soluble. So A is not the answer. Strontium sulfate is more soluble. So this is actually compared to the magnesium sulfate. So magnesium is above strontium. This means that the magnesium sulfate is more soluble because I told you sulfate solubility decreases. So strontium sulfate is less soluble than magnesium sulfate. Then the strontium nitrate has lower thermal stability than calcium nitrate. So calcium is also above, it is also above your strontium. This means that the strontium nitrate will have more thermal stability. So C is also not your answer. Then the D says strontium is a stronger reducing agent than magnesium. Okay, so magnesium is above the strontium, and now what actually happens is down the group the size is actually increasing. Okay, down the group the size is increasing, which means there is less attraction of the nucleus towards the electrons. So there is less attraction to electrons. So this means that it can easily reduce the electrons. So you can just say that it can easily lose the electrons, or you can just easily reduce the other one. Okay, because the losing electrons is actually oxidation. So it is oxidizing itself and it is reducing the other one. So it is actually acting as a reducing agent. So D will be your answer. Let's move on to MCQ 20. So now question number 20 says that sodium bromide is warmed with concentrated sulfuric acid, which describes the change in the oxidation number of the sulfur and the role of bromide ions in the reaction. Now this is the reaction of halide ions with the sulfuric acid. So you should remember that first of all that the chloride ions only have acid base reaction. Okay, they are not a reducing agent and they cause no reduction in the oxidation number of sulfur. So they only have a acid base reaction. Only the bromide and iodide ions actually undergo the reduction. Okay, they reduce the sulfur. So what actually happens is that first of all the NaBr, because we are looking into bromide ions here, so the NaBr actually reacts with H2SO4, and this actually forms NaHSO4 plus HBr, and then this HBr further reacts with H2SO4 to form SO2 plus H2O plus Br2. Okay, so this is actually it reduces it one time only, while in the case of iodide the reduction happens two times. For example, after sulfur dioxide it will go to sulfur and then it will go to H2S. Okay, so this is the oxidation state of you can say the lowest oxidation state in the SO2. So let's see what is the oxidation state of the sulfur in the SO2. So it will be S plus minus 2 for oxygen into 2, because there are two atoms, is equals to 0. So it will become S minus 4 is equals to 0. So S will be equal to plus 4. Okay, and what is the oxidation state in H2SO4 in the sulfuric acid? It is plus 2, because plus 1 into 2, and then we have plus S, then minus 2 into 4 is minus 8 is equals to 0. This will become minus 6 and S will become plus 6. So it is going from plus 6 to plus 4. Okay, so plus 6 to plus 4, and it is acting as a reducing agent because it is reducing the sulfur. So B will be your correct answer. Let's move on to question number 21. So question says a reaction occurs when ammonium chloride is added to calcium hydroxide. What is the role of the ammonium ions in the reaction. So for example, if we have the ammonium ions, so ammonium, which is NH4 plus, and we have Cl minus, it is actually reacting with calcium 2 plus and OH minus 1. So what actually happens is that the NH4, you can say the ammonium ions, they have one more proton, or you can say one more hydrogen atom. So it actually donates it to this OH, and it actually forms H2O, and then the Cl will combine with the calcium 2 plus, so it becomes CaCl2, and then we have NH3 liberated, okay, because the one of the proton is donated. So whenever we say that a substance is donating a proton, what we say that it is an acid, okay. Remember, NH4 ions are behaving as acid, while the NH3 is a base. So the answer for this one will be A. Let's move on to question number 22, which says that element Y and Z are both in the period 3. Element Y has the smallest atomic radius in period 3, and there are only 2 elements in period 3 that have a lower melting point than element Z. Okay, so element Y and Z are reacting together to form a compound R. What could be the compound R? Okay, so let's see first of all. So I have actually taken out these 2 graphs. So first of all, for element Y, they told us that it has the smallest atomic radius. So you can see that this chlorine has the smallest atomic radius in the period 3, because after that we have the inert gas argon, and which we do not consider because it does not perform in the reaction. Also, it has more you can say atomic radius. Okay, so the chlorine will be the element Y. So element Y is your Cl2, and then for the element Z, they told us that only 2 elements have lower melting point than element Z. So you can clearly see that this is the phosphorus, because there are only 2 elements below the phosphorus, which are chlorine and argon. So the answer for the element Z will be phosphorus. Okay, so if I react phosphorus and chlorine, it can form P4 plus Cl2, so it will form PCl3, or you can also form PCl5. Okay, so D will be your answer for this case. Then question number 23 says that 1 gram of each of the 4 compounds of group 2 elements are thermally decomposed. The residue in each decomposition is the oxide of group 2 element. The volume of gas from each reaction is measured at room temperature, which substance produces a greatest volume of gas. So first of all, for this question you should know the equation. Okay, so we are actually undergoing thermal decomposition. So this is calcium carbonate, CaCO3. This will decompose to form calcium oxide, plus it will also form oxygen, okay, O2. So let's see if the equation is balanced. So yes, it is balanced. Then for the calcium nitrate, it will be CaNO3 whole twice. It will decompose to form calcium oxide plus 2NO2 plus half oxygen. Okay, I have already balanced this equation. And then we will have for the strontium carbonate, so it will be SrCO3. Okay, and it will also give you strontium oxide plus oxygen. Okay, so now you can just calculate each one of them, because we have 1 gram of this strontium carbonate. Okay, so you can just calculate for each of them you can say the moles, and then through the moles you can just use the balance equation to predict that what is the moles of the gases, and then you can just multiply that the moles of gases into 24 dm cube to get the, you can say, the volume of gas. Okay, you can just multiply with the 24 dm cube or 24,000 cm cube. So first of all, I will just do it directly for the calcium nitrate because I already know the answer. Okay, so just to save time, you can just do it for the other ones as well. So what, first of all, what I will do is that what I will find the MR of calcium nitrate. Okay, so it will be calcium MR is 40, then plus nitrogen is 14 into 2 is 28, and then oxygen is 48 because it is 16 into 3. Okay, so it is 16 into 3, so 48 into 2, let's see what it is. So 48 into 2 is 96, so it will be plus 96. Let's see what the MR of whole compound is. So 40 plus 28 plus 96, it is 164. Okay, so 164 grams. Let's see the moles of this compound. So it is 1 gram divided by 164. Okay, mass over MR, so it will be 1 divided by 164, which is 0.006097. 0.006097. Okay, and now you can just use the balance equation. So you have to multiply this mole. So for this one, let me just pick up a different color. So it will be 0.006097, okay, into 2, and then for this one it will be 0.006097 into half. Okay, so let's see. So 0.006097 into 0.5, and then plus, let's see. Okay, so then we have 0.006097 into 2. Okay, so it will give me the total mole of the gases. So it is giving me 0.015 moles. So let's just now calculate the volume of gases. So 0.01524 and then into 24 dm, so it will give me the answer 0.36 dm cube. Okay, you can also do it for the rest one and you can check. Okay, so B is actually your correct answer. Now question number 24 says sulfur dioxide in the atmosphere can form acid rain. This occurs in 2 steps. First of all is the oxidation of the sulfur dioxide to sulfur trioxide, and then the second is the formation of dilute H2SO4. So which will identify the atmospheric catalyst for step 1 and the reagent for step 2. So you should know that the oxides of nitrogen acts as a catalyst. Okay, so the catalyst is oxide of nitrogen. Okay, NOx. Okay, so it can be any it depends on the number of oxygens. Okay, so what actually happens is, for example, if there is NO2, it will react with this SO2, it will donate one of its oxygen and it will form NO plus SO3, and then this NO will further react with the atmospheric oxygen to form NO2 again. Okay, so this is acting as a homogeneous catalyst. Okay, it is just recreated at the end. And then for the you can say the SO3, it will simply be reacting with the you can say the water of the rain. Okay, and it can form H2SO4. Okay, so H2O and NO2. Okay, so it means the C is your correct answer. Let's move on to question number 25. So question number 25 says, which statement about the mechanism for SN1 reaction of halogenoalkane is correct? Now it means SN1 is a nucleophilic substitution reaction, and it is actually for the tertiary halogenoalkane. Okay, it is for the tertiary halogenoalkane, and also the SN1, the 1 indicates here that it is only one reactant in the slow step, one, or you can say in the rate determining step. Okay, so let's see what the statements are. So a nucleophile is substituted by electrophile. This is correctly wrong, because we know that it is nucleophilic substitution. Okay, it is being substituted by a nucleophile. So one intermediate is formed from two reacting molecules. So I just told you that there is only one reacting molecule. Okay, that's why it is named as SN1. Now the C says the intermediate is stabilized by the adjacent alkyl groups. This is correct, because it forms a carbocation. Okay, and that carbocation is actually balanced by the positive inductive effect of the alkyl groups. Then D says the intermediate is uncharged. This is also incorrect, because we have a carbocation and it has the carbocation actually have the plus charge, because if you remember, in the case of the SN1 reaction there is a static hindrance. Okay, so actually the bond between the nucleophile and the carbon will automatically break. Okay, so there are no two reactants, there is only one reactant, and then the nucleophile will attack the carbocation. Okay, so the C will be your correct answer in this one. Question number 26 says the repeat unit of the polymer is shown. Okay, so which statements about this polymer? Okay, they have stated three statements about the polymer. Okay, and which statements are correct? Let's see. Okay, so first one says that it disposable is hazardous because it produces toxic gas when burned. Now this statement is correct, because whenever you see chlorine in any of the polymer, this means that it will be, you can say, if you burned it, or for example if it is combusted, okay, it will always form HCl fumes. Okay, and that are toxic. So this statement is actually correct. Now the second statement says two different monomers are used to make this polymer. Now how are we going to be deciding that whether one or two polymers are being used to make it? Okay, so first of all, if I just try to make the monomer of this, what I will do, I will just try to flap this again. Okay, so I can form the double bond. Okay, and I will also do it. Now I will actually lose one of the hydrogen. Okay, but if I try to actually unwind this again, what will actually happen is that this carbon is already saturated, so it has a maximum number of bonds. Okay, so I cannot do this. Okay, I cannot do this. So what it actually suggests is that there is two monomers, which is the first one will be this one. Okay, let me just highlight. The first one is this one, and the second one will be this one. This is what actually it suggests. So it will be C double bond C, and there will be Cl and H and H and H. Okay, so and the other one will be C double bond C. Okay, if I try to unwind this one and this one, so it will be C double bond C, this will be OH, this will be H, this will be H, and this will be H. Okay, so these two monomers are actually reacting together. So this part is also correct. So whenever they are asking you about whether two or one monomer is used, you just have to unwind and check whether it is you can say the carbon it is bonded to, whether it's saturated or not. Okay, because in that case it will try to take the hydrogen from that one. So the third says the monomer for this polymer is 3-chloro-butene 1-ol. Okay, so first of all let's make the structure of butene. So but and 2-ene. Okay, and 3-chloro. Okay, so 3-chloro-butene and 1-ol. Okay, so now what we actually suggested is that there were two monomers in this shape. Okay, so we actually said that it was in this type of you can say arrangement. But now what actually they are suggesting here is that the double bond is in between, which is totally incorrect. Okay, so this statement will be incorrect, because if I have a double bond in between, then how will actually we have you can say when the double bond opens, how are we going to be having this? Okay, and at the other end it will be only in the between. Okay, so in case if I have this statement, you can say this type of arrangement, it will actually form something like this. Okay, and we will have C, and this will be bonded to OH, and this will be C, and this will be C bonded to Cl. It will be something like this. Okay, it will not be in the other arrangement, so this will be incorrect. So this means that 1 and 2 statement are only the correct answer. Okay, let's move on to question number 27. So methanoic acid HCO2H has acidic properties similar to those of carboxylic acid. In addition, it can be oxidized by the same oxidizing agents that are capable of oxidizing aldehydes. Now, in your syllabus of the AS, you have studied that the carboxylic acid cannot be further oxidized, but in your A2, when you will be studying, you will know that the methanoic acid and the ethane dioic acid are the only two type of acid that can be oxidized further. Okay, so now they have just given you the information, and based on this information you have to just conclude. Okay, so they have told you that they are capable of oxidizing agent, the oxidation agent that are capable of oxidizing the aldehydes, they can also oxidize the methanoic acid. So which pair consists of compound that will give the same observation with the failing reagent? Okay, so what actually happens with the failing reagent is that the failing reagent can oxidize the, or you can say the aldehyde. Okay, it is a slight oxidizing agent. Okay, so it can oxidize the aldehydes. And now based on the information they have given you, that the reagents that can oxidize the aldehydes, they can also oxidize the methanoic acid. Okay, so this is your methanoic acid. Okay, and let's see where is your aldehyde. Now here, this is actually your carboxylic acid. Okay, so this will be incorrect. Now this is actually your ester. Okay, or you can say actually it is your ketone. Okay, sorry for that, it is your ketone. So this is your ketone, so this will also be not your answer. This one is also a ketone, and the last one you can just see here is that this is your aldehyde. Okay, this is propanol. So aldehyde and the methanoic acid will give the same result with failing reagent. So this means that D is your correct answer. Let's move on to question number 28, which is that which row gives pentane nitrile as one product. Okay, so you should remember that whenever now they have given you that the halogenoalkane, okay, that it means that a carbon that has been bonded to a halide ion. Okay, so actually what happens is that you have to take KCN and then you have to heat. Okay, but the KCN should be dissolved in the ethanol. This is something that you have to remember. Okay, and the halogenoalkane that you have to take, it should have one carbon less. For example, if you are going to be making pentane nitrile, you should have the carbon chain of butane. Okay, it should be like this. So 1 2 3 4, and then you should have a Br here. Okay, so actually what will happen, that the Cn will actually replace this one, and the Cn actually have the carbon, so it will then form a 5 carbon chain. So this is 1 2 3 4. Okay, so this looks perfect, and then heat with KCN using the ethanol as solvent. So B is your answer for this question. Now question number 29 says that in ester, now they have given you the R prime as one of the side chain, and then we have the CO2, and then we have the R double prime, which is the other side chain. Okay, so it is hydrolyzed in the alkaline conditions. Okay, so R prime and R double prime are different alkyl groups which will identify the two products formed. Now this is the ester. Okay, this is the ester. For example, if this is the R prime that is bonded to CO2, and then we have the R double prime. So what actually happens in, you can say, the alkaline conditions is that you have no H plus ions. Okay, so this means that the, you can say, the acid is hydrolyzed to form a carboxylate ion. Okay, it forms a carboxylate ion in your alkaline condition, and in your acidic condition what actually happens is that the H plus ion will then react with this carboxylate ion to form a full acid. Okay, it will give you your acid, while the, or you can say the alcohol is obtained. Okay, so the alcohol is obtained, you can say the R double prime OH will remain as it is. Okay, it will be obtained, while the carboxylate ion will be obtained for the acid. Okay, there will be no formation, or you can say you cannot obtain your acid in alkaline conditions. So B will be your correct answer for this one. Now question number 30 says, which compound cannot be oxidized by the acidified potassium dichromate? So you know that the oxidation of the tertiary alcohols can't happen, and but does react with sodium metal. This means that it has a OH group. Okay, so let's see the first option. Okay, so this is CH3, and then we have three side chains which are bonded to C, which is the carbon, and we have a hydroxyl group. So it is something like this. Okay, let me just give you the idea. CH3, CH3 and CH3, and we have a OH here. Now you can say this is a saturated carbon. Okay, this is a saturated carbon atom. Okay, this cannot be further oxidized, while it has this OH group which can react with metal. Okay, so this can be your answer. Let's see the other ones as well. So the second one is actually CH3CO CH2CH3. Now this cannot actually react with your this cannot be oxidized because it is a ketone. Okay, but this can also not react with your sodium metal because this does not have a OH group. So this is not your answer. Let's move on to C. So C is actually, you can say this is a primary alcohol. This can be oxidized, and it can also react with the sodium metal. So they are actually saying that it cannot be oxidized. Okay, so the first statement is actually invalidated. So this means that C is also not your answer. For the D, we have a secondary alcohol, so it can also be oxidized. This means that A is your answer. Now 31 says, butone reacts with alkaline I2 and excess of dilute sulfuric acid is added to reaction mixture. The organic product of this reaction sequence are triiodomethane and product M. So actually, first of all, you have to write that what actually happens. Okay, so butone. Okay, so 4 carbon ketone, so it is 1 2. Okay, and then we will have double bond O C C. Okay, so first of all, what will actually happen, that here we actually have you can say a methyl chain. Okay, this is your methyl chain, and now what will happen is that when it actually reacts with the alkaline I2, which is the iodoform test, it is actually, whenever the methyl chain is directly bonded to the carbon which has the ketonic group, or it has the hydroxyl group, then it will actually give you a yellow precipitate of triiodomethane. So what actually happens is that this CH3 is converted into CHI3 triiodomethane, and for the other part, for this part, let me just encircle this. To this part, what actually happens is that this will remain C double bond O C C, and we will have O, and then we will actually have a formation of a carboxylate ion. Okay, it will always form ion, but here we have a twist. Okay, it is not as simple as it looks. They have added excess of dilute sulfuric acid. This means that the sulfuric acid is actually providing it the H plus ions. So when the H plus ions will react with that, this will actually form HOC double bond O, and this will be C2H5, which is actually your propanoate ion. Okay, so C will be your answer for this. Sorry, this is not the propanoid ion, it is the propanoic acid. Okay, the propanoid ion will be formed if there is no sulfuric acid. Okay, but now the sulfuric acid will provide the H plus ion, so it will form propanoic acid. Now question number 32 says 4 reagents are listed. Okay, so they have given you that aqueous, KCl, dilute HCl, liquid SOCl2, and the phosphorus pentachloride. Okay, so which reagents when added to ethanol will rapidly produce a gas that turns blue litmus red? It means that it is a acidic gas. Okay, so which one reaction produces a acidic gas? So you should know the equation for all of them. Okay, first of all, with ethanol the KCl does not react. Okay, so this is already eliminated. You can just eliminate the options which have the one. Okay, so in the case if it does reacts, it will only and only replace the OH with the Cl. Okay, there will be no formation of fumes. Now for the HCl we do know the equation. Okay, so for example, if we have ethanol which is C2H5OH, it will actually react with the HCl. Okay, and then it will form C2H5Cl. Okay, it is being substituted plus H2O. Now you can see there is no toxic, or you can say the acidic gas is not produced. Okay, so 2 will also not be your answer. Then we have liquid SOCl2. Now for the SOCl2, the ethanol will react. Okay, so it is SOCl2 with the ethanol. It will actually first of all substitute. Let me just write this. So it will first of all substitute the OH with the Cl, and then it will form HCl steamy fumes plus your SO2. Okay, sulfur dioxide. So now you can see that it actually forms the HCl, which is acidic, and it will turn blue litmus red. So this is your answer. And then for the PCl5, what actually happens is that the C2H5OH will react with PCl5 to form C2H5Cl plus it will also form HCl plus POCl3. Okay, so it also forms HCl. So this will also be your answer. So you just need to remember these equations. Okay, so D will be your answer, 3 and 4. Question number 33 says that 4 drops of 1 chlorobutane, 1 bromobutane, 1 iodobutane are put separately in 3 test tubes containing 1 cm cube of aqueous silver nitrate at 60 Celsius. In each case, a hydrolysis reaction occurs. So R represents C4H9, which is actually your butyl side chain, and X represents the hydrogen atom. The rate of formation of cloudiness in the test tube is in the order. So actually the RCl, the time for that one for formation is, you can say, the small. Okay, it has the you can say it has the most amount of time, and then we have the RBr. Okay, the side chain with the bromide ion. Okay, the bromide atom, and then we have the side chain with the iodide atom. Okay, so what this actually means is that your reaction with, or you can say the rate for the cloudiness is the reaction with iodide ions are fastest. Now what actually this gives you the sense? This means that the bond between the side chain and the iodide atom is the weakest bond. Okay, this is the weakest bond. So what actually happens is that when we progress from the chloride then to bromide and then from to iodide, okay, so what actually happens is that the size of these halogen atoms increases. Okay, so the size of halogen atom increases. Okay, so what actually happens is that the bond overlap actually is less efficient, and it is much easier to break because there is less nuclear attraction towards the straight pair of electrons. So you can just clearly say that the bond energy decreases from uh, side chain with the Cl to when you progress downwards to a side chain with the iodide. Okay, so it will be the answer will be A, which says that the bond energy of Rx decreases from RCl to Ri. Okay, that's why the Ri is will break more easily. So the reaction, or you can say the rate of formation of cloudiness, is the fastest in that one. Okay, now second statement says the first ionization energy of the halogen decreases from the Cl to iodine. So this is clearly incorrect because ionization energy has nothing to do with it. Okay, so, and even if you just think with respect to the ionization energy, it will decrease down the group. Okay, so what actually happens is that it is actually suggesting you the bond, you can say the bond inefficiency. Okay, it means that it is decreasing. It means that it needs less energy to remove one electron. Okay, but it is correct, but it does not you can say it is not valid to the context of this question. Okay, the main reason for, you can say, the rate of formation is the bond energy. Okay, that how easily the bond can be broken. Same for the solubility of AgH decreases from AgCl to AgI, so this also has nothing to do with it. And the Rx bond polarity decreases from RCl to Ri. The polarity does decreases, but here we are talking about the bond energy. Okay, so these statements are correct, but it does not actually match the context of the question. Then question number 34 says that propanoic acid reacts with LiAlH4, which is lithium aluminium hydride. Okay, it is a reducing agent, so this is actually a reducing agent to give organic product P. So methanoic acid reacts with organic product P in the presence of a few drops of concentrated sulfuric acid to give organic product Q. Okay, so for example, if you are reacting with the propanoic acid with the reducing agent, so it will form propanol. Okay, it will form 1, 2 and 3, and then we will have a OH here. It will form propanol because it is reduced. Okay, so acid reduces to alcohol. Now methanoic acid will react with the organic product P, which is actually your propanol, in the presence of few drops of sulfuric acid to give organic product Q. Okay, so now the propanol and actually this is all, and the methanoic acid actually reacts. Okay, so this will give you ester, and what will be the name of ester? Its name will be propyl methanoate. You should remember that the first name is always of the alcohol and the second one is for the acid. Okay, so let's see. Okay, it will form something like, first of all, we have a methanoic acid. Okay, so it is C double bond O, only one carbon, and OH, and we will have a H here, and then we have a propanol, so it is actually OH bonded to C, then we have C and C. So actually what will happen, that this whole OH and one of the O will be condensed to form H2O. So it actually forms something like this, C double bond O H C. Actually it will be, let me just correct this. Okay, I just by mistake selected the oxygen. It will be HO. Okay, so 2H and 1 oxygen will be condensed to form H2O. So we'll have O here, and then C, C and C. So let's see at which structure matches this one. Okay, so for the organic product it should be propanol, so 3 carbons, so 1, 2 and 3. Okay, 1, 2 and 3, and we should have OH. So these two actually seem correct because in the third one we actually have the double bond O, so these are not correct. Let's see for the organic product Q, which is actually your ester. So it should have one carbon, okay, one carbon acid, and then we should have 1 2 3 carbon alcohol side chain. So B seems correct, because in the first one you can see that we have 1 2 3, we have a 3 carbon acid and 1 carbon alcohol. Okay, so they have just reversed that in the first one, so B will be your correct answer. Let's move on to question number 35, which says sample of the gases CH3Cl and Cl2 are mixed together with and irradiated with ultraviolet light. Which compound is formed by termination step in the reaction? So this is actually free radical substitution. So free radical substitution. Okay, and what are the possibilities of the formation? Okay, so first of all, what can happen is that CH3 can actually form a radical. Okay, this can actually form a radical, and you can also say that one of these hydrogen can also form a radical. Okay, so this can also happen that we have a CH2Cl and a radical here. Okay, but what cannot happen is that there can be no formation of hydrogen. Okay, there can be not a formation of a single hydrogen atom, so D cannot be correct. And then for the B, we cannot actually form a double bond. Okay, now what can actually happen is that this Cl2 can actually form two chloride radicals. Okay, but because we do not have a radical of the hydrogen, okay, so it can also not also form HCl. But we have discussed that we can have one hydrogen removed. Okay, we can have one hydrogen removed, and then we can have the radical with the chloride side chain. Okay, so two radicals like this would actually form CH2Cl and CH2Cl. This means that C can be your correct answer. Okay, and question number 36 says propane 1-ol C3H7OH is dehydrated. So whenever alcohol is dehydrated, it forms alkene. Okay, remember, it forms a alkene, and in this case the alkene will be propene. Okay, it will be propene. So is dehydrated by passing its vapor over hot aluminium oxide to give a hydrocarbon. It can also be dehydrated because it can also be dehydrated using H2SO4. Okay, so which structure formula represents a product obtained when the hydrocarbon reacts with bromine? Okay, so now they have reacted this propene with Br2. This means that there will be electrophilic addition. Okay, so we will have let me just draw the structure here. Okay, so for example, if this is propene, okay, if this is your propene, so what will happen that the double bond will break and we will have the bromine attached to first two carbon atoms. Okay, so you can just see that here we have one bromine, so this is this does not match that what we have drawn. Here we have one bromine as well. Okay, so this means that A and B can't be correct. For C, you can see that we have the bromine on the same carbon. Now this is not possible, okay, because the double bond is breaking between two carbon atoms and we will have the bromine attached to that two carbon atoms. So this is also wrong. Now D is correct, and it also matches the what we have drawn. Okay, so D is your correct answer. Okay, so because if you consider this as first and this is second, this is the same as if you consider this as first and this is second. Okay, so it just means the same thing. So D will be your answer. Let's move on to question number 37. So question number 37 says alkane S has molecular formula C4H10. Okay, so it is butane. So S reacts with chlorine. Okay, so in the presence of sunlight to produce only two different monochloroalkanes. So first of all, let's make the structure. Okay, so if this is your C4H10, let's make the structure. So 1 2 3 and 4. So 1 2 3, and then they have said that it makes two different monochloroalkanes. Monochloro means that one chloride atom. Okay, so if we have one chloride atom here, okay, this is one of the possibilities. And let me also show you what can be the other possibility. Because if you see from this direction, it is actually the carbon number 2. And if you see from this one as well, actually this is your carbon number 3. Okay, so let me just make the second possibility as well. So it will be if we have a chloride bonded to first carbon atom. Okay, so it will be something like this. But in the butanes, actually the IUPAC naming structure says that whenever we are actually saying that this is the first carbon or the second carbon, we should always choose from the side that is nearest to that carbon, that atom. Okay, for example, if there is a hydroxyl group, you should always change. You should also always start the naming from the side from which the atom is at the closest position. Okay, so we will start the naming from this side. Okay, and it will be 2-chloro actually. Okay, so and in this case it will be 1-chloro. Let me just complete the number of hydrogens. Okay, so in this case we will have 1-chloro. Now these are two different monochloroalkanes that can produce, which is C4H9Cl. Okay, so both of these monochloroalkanes are treated with hot ethanolic KOA, potassium hydroxide. Okay, and what it actually does is that you can say that it actually dehydrates, or you can say elimination reaction. Okay, elimination reaction occurs, and there is a formation of a double bond. So they both produce the same alkene T and no other organic products. Okay, so first of all, let's just reduce the size of this so I can make the structure of T. Okay, so now what will actually happen is that if for example if this chlorine atom is removed, or this one is removed, there can be the formation of, you can say, double bond here, or it can also be the double bond formation here. Okay, so first of all, let's see. And also now they have told you that when it is produced, then the tea is treated with hot concentrated acidified KMnO4. This means that now it will actually undergo the reaction in which we say that, for example, if there are two side chain with the carbon atom, it will form a ketone. If there are no side chain, if there are only hydrogen, it will form carboxylic acid plus H2O, and if there is only one, it will form your acid. Okay, so for example, let's suppose the structure of T, it should look something like this. Okay, if it looks something like this, it will be C, and then it will have C. Okay, so actually this has one hydrogen and one carbon side chain. Okay, so for example, if this structure actually reacts with your KMnO4, because on the one side we have two hydrogens bonded, so it will form CO2 plus H2O. Okay, and for the other side it will form a carboxylic acid. Okay, it will form a carboxylic acid. Now if I suppose that the carbon double bond is being made between the second and the third one, so if this is something like this, okay, so then in the both cases, if I just react it with the KMnO4, what will happen is that it has one hydrogen and one carbon side chain. Okay, so what will happen, it will form acid only. Okay, it will form carboxylic acid only. Okay, but now we actually they are saying that we are actually it forms the same thing. Okay, so because they are saying that it actually forms the same alkane, which is T. Now you can just see that when this chloride is actually, you can say, eliminated, this can form the bond either between the first and the second, or the second and the third. But if the first one is eliminated, it can only form the bond between first and the second. Now if we are actually assuming the situation in which they both produce the same alkene, then it should be between the alkene with double bond between first and the second. Okay, this can only be the situation in which both have the common thing. Okay, so we will consider the first one. Okay, so CO2 plus H2O and the carboxylic acid. So it is 3 carbon acid, so it will be this one. Okay, and so it will be A. Okay, the answer for this one will be A, because for the second one it is a ketone, this is not an acid. Okay, so B will not be correct. For the C we only have the acids. Okay, it is not possible. And D is the only possibility if we have a carbon between the second and the carbon double bond between the second and the third one. Okay, then question number 38 says, including structure isomers and stereoisomers, how many isomers are there of C2H2Br2? So if you make the structure for this one, so it is actually C2, so 2 carbons, 2 bromines, okay, and 2 hydrogens. This means that there is a double bond here. Okay, so this is your one structure. Okay, let's just list them down. This is your first structure. Then for the second one, we can have it like this. Okay, we can have a cis structure. Okay, it will be something like this, but in this case we have on the same side. Okay, we have the Br on the same side, and then we will have H and H, and on the third possibility can be the trans. Okay, so it will be Br here and Br here, and we will have H and H. So these are only the 3 possibilities, so this means that B will be your answer. Okay, let me just remove this because we also have to attempt the question number 39. So question number 39 says that which compound exhibits stereoisomerism? Okay, so stereoisomerism actually includes your optical, in which you have the carbon bonded to 4 different groups, and you also have the geometrical, which is cis trans. Okay, but in this case you have no double bond, so geometrical is not possible. Okay, so first of all they are saying is 1,1-dichloropropene. So okay, so they have given you the alkene as well. Okay, so this means both are possible. So 1,1-dichloropropene, so it is propene and 1,1-dichloro. Okay, so 1,1-dichloro. Okay, so in this case you can see that we have a hydrogen here, and we also have a hydrogen and hydrogen and hydrogen. So you can see that for the cis trans to be possible, actually we should have 2 different groups. Okay, so here we only have the same type of groups, chloride, that are bonded to the first carbon. Okay, so it means that the geometrical isomerism is not possible, and for the optical isomerism you can see that there is no carbon that is bonded to 4 different groups. Okay, now let's suppose the second one. Okay, so it says 2,3-dichloropropene. So if this is the propene and we say it is 2,3, let's suppose it is 2,3, it is 2 and 3 dichloropropene. So you can just say that here we have the same hydrogen that is bonded to the same carbon. Okay, so this means that the cis trans is not possible as well in this one. Okay, so the same case, so this is also not your answer. Then we have 1,2-dichloropropane. Now this is not an alkene, this is a alkane. So 1, 2 and 3, so 1, 2, it will be Cl, and we have a Cl here, and we have hydrogen hydrogen and hydrogen. Now in this type of structure the geometrical is not possible, but if you see one thing here is that this one actually bonded to two hydrogen. Okay, so it means that there's no four different groups, but if you see for this one, it is actually bonded to four different groups. One is the Cl, one is the carbon methyl side chain, one is the hydrogen, and one is the methyl chain with a chloride. Okay, so these are four different groups, so C can be a possible answer. Let's also check the D one. So it says 1,3-dichloropropane, so 1 2 3 and 1 3, so it will be Cl and Cl here, so H and H and H and H and H and H. Okay, so if I have 1 and 3, let me just remove this. Okay, so it is 1 3. Okay, so it is 1 3 dichloropropane. So you can see that none of the carbon has actually four different groups. Okay, this one has two hydrogen, and this also has two hydrogen, and this one also has two hydrogen. So this means D is not also your answer, so C will be your correct answer. Okay, let's move on to question number 40, which is the last question. So the mass spectrum of CH3Cl shows a molecular ion peak M+1. So M+1 is actually your you can say the mass of the molecule, mass of your molecule. Okay, and it has a value of 50 with the relative abundance of 18%. Other peaks are present in the mass spectrum. What is seen that the mass spectrum of the Me value of 15? Okay, so you have to tell the abundance. You can say the abundance of peak with mass to charge ratio of 52. Okay, so now you can say that between 50 and 52 there is a gap of 2. Okay, and for which one actually you can just remember this, that for chlorine we have one isotope that is chlorine 35 and the other one that is chlorine 37, and because of this there is a difference of 2 created between two peaks. Okay, so for example, if the one with the 50 was 18% abundant, okay, so you should know that it is a 35, because for 37 we will have an increase by 2, and you should know that the 35, its abundance is 75%. Okay, and for the 37 we have an abundance of 25%. Okay, so now you can just simply work this out. So if this is actually the you can say this is the 3/4 of a ratio and this is the 1/4 of a ratio. So if 3/4 of the ratio is 18, what will be the 1/4 of the ratio? It will be 6%. Okay, so let's see what statements actually agrees to us. Okay, so a peak with the relative abundance of 4.5, this is incorrect. A peak with the relative abundance of 6%, so this is correct. And a peak with the relative abundance of 18%, this is incorrect as well. It cannot be the same. And then D says a peak with the relative abundance of 54%. Now this will be the case if in the case if your for example, if they have given you the 52 with the 18% abundance, in that case the 51, or you can say the one with the isotope of 35, okay, it will be 3 times of the 18. Okay, but in the case if 18% was of the 52, okay, or you can say the isotope with the 37. Okay, so in that case the 51, or you can say the peak with the Me value, mass to charge ratio of 50, in that case it would be 54. Okay, so this is not correct. Okay, so this means that B is our correct answer. Hope this was understandable and we have actually completed this whole paper. Okay, so in the case if this was beneficial, do like the video, do share the video and subscribe the channel. I'll be meeting you with another video. If you want a PDF of this paper, you can just check in the description down below. Okay, so I'll be meeting you in another video. Till then, take care and goodbye.